So last time we dealt with this. Let's do an example of what we did last time. There was this idea that we had. We've had this problem that we have a map. So here's an example of a map. A simple map. Okay, so it's from R2 to R4. Okay, and you can the question, and so there's two kind of problems we did. One was you choose the standard basis like here, and this would be E2, and the standard basis here E4, and then you ask what's the matrix F that represents this, and you know, you take the columns will be the images of the basis action of the function. You take 1, 0, and you'll see that F is going to be 1, 0, 1, 0, right? Because the image of the first standard basis vector 1, 0 is just 1, 0, 1, 0, and the other one is going to be 0, 1, 0, 1. So here is a simple, and then the question is, well, what happens if you wanted to find, this is standard, and we've had the problems. What happens if like B is a different basis, say 1, 1, 1, minus 1, and over here we had a different basis here, say 1, 1, 0, 0, 1, minus 1, 0, 0, 0, 0, 1, minus 1, 0. Well, let's choose this. 1, 1. No. Okay, I'm not drawing a matrix. I'm doing basis elements. So I need to put parentheses in here. I'm just going to draw the same. Just maybe barely get in there. Okay. Was 0, 0, 1. Minus 1. Okay. So the idea was that if we want to find F that takes you from this map F from basis B to basis D, what we've done in the past is just the straightforward way of taking this vector, finding the image, right? And then taking that image and representing it and doing a little linear system problem. We expand that in terms of this basis and find the coefficients, and we find the matrix. And then but last time we sort of looked at a way to try to understand why that thing works. And the idea was we have, I'm going to repeat the information just so we can see it. This is sort of we have right like that, and then this is in epsilon 2, epsilon 4, and then we have let me use different. I'm just going to use different letters. WX, say what. We want to be able to take. I don't want to use the same letters because it'll be confusing. Okay, so XY, say Z and W. Now let me use R and S just so that it's not R and S, and we want to know what the image is where this thing is going to be in basis D, right? So there's the map F here, the matrix F. it's the same map in both cases, but the matrix here is epsilon, epsilon, and the matrix here is going to be B, D. Okay, so the idea then is that in order to find this map, we can first go from basis, find the identity matrix from basis B to E2. Well, let's do that. So basis B is 1, 1, 1, minus 1. And it's going to the standard basis. So we look at, we want to find this matrix here. So we find the image of 1, 1. What is the identity map? So we get 1, 1. And then we want to write this as we want to see, well, what's the matrix that does this? Okay, well, this is just going to be 1 times 1, 0. So this is in the standard basis. And then 1 minus 1 is just 1 minus 1 in the standard basis. So this matrix here is just 1, 1, 1, minus 1. Okay, but then we also see, so if we start here, instead to go way across, we can go up this way, then across with FEE. Then we need to go down this way from E4 to D. So we need I E4 to D. So that it's like this. This was B E2. This is E4 D. Okay, so we need this matrix here. Well, this one we start from. We need to look at the identity matrix for the standard basis in terms of D. So let's, what was D? D was this one here. D was 1, 1, 0, 0, 1 minus 1, 0, 0, then 0, 0, 1, 1, 0, 0, 1, minus 1. And so we want to know, let me see, this is going to, oh, I did the wrong one. Yeah. Okay, so I need the image for the identity that's going to go from E4 to D, right? So that means I have to look at the images of this first one is going to go to 1, 0, 0, 0. And I have to then see, well, what is that in this basis here? Well, you can see that it's going to have, I'm going to have like an A, a B, a C, and a D. And because there's zeros down here, I'm definitely going to take C equals D equals 0 because there are no numbers here. So and these don't interact up there. So this is going to be A times this plus B times this. And I want to cancel off. So if I just add these together, if I just take A and B to be equal, the second one will cancel off, the 1 and the minus 1, and I'll end up with 2 here. So what I'm going to end up with is A equals B equals 1/2. We did something like that earlier. And so this one is going to be 1/2, 1/2, 0, 0 in basis D. Okay, and then we can sort of see how it's going to go. 0, 1, 0, 0 is going to go to 0, 1, 0, 0. And that's going to equal, well, again, we want to cancel off the first one. So we take them A to B to be minus A. So the top ones will cancel. And on this one, since B, since B is minus A, this will add. So we want the numbers are going to be 1/2 minus 1/2, 0, 0. And then the whole thing is going to repeat down here for 0, 0, 1, 0. That's going to go to 0, 0, 1, 0, and which will equal 0, 0, 1 half, 1 half in basis D. And this one down here, 0, 0, 0, 1. So now I'm regretting choosing a four-dimensional space. 0, 0, 1 half, minus 1 half D. So you can see that I E4 D should equal 1 half, 1 half, 0, 0, 1 half minus 1 half, 0, 0, 0, 0, 1 half, 1 half, 0, 0, 1 half, minus 1 half. Okay, well, and it turns out that this was a fair bit of work. We could then put, if once we had these identity maps, these change of basis maps here, we could then use it for any map up here, right? So now we can calculate F E2 to E4. So over here, we're going to have, well, what is this? See, this goes from E2 to E4. So if we act with F here, it's going to be E2 to E4. So we need on this side to start from B to E2 because, I mean, the other way around. Yeah, we want to go from B to E2. Then this takes us from E2 to E4. Then we need here E4 to D. So let's multiply all this together and see what comes out. So on the left, we're going to have this big thing. 1 half. Well, you notice that every non-zero entry has a 1 half in it. So I can just factor out the 1 half from the whole matrix, leaving ones behind. It'll be much easier to write. So I can pull out a 1 half, then put here 1, 1, 0, 0, 1, minus 1, 0, 0, and then 0, 0, 1, 1, and 0, 0, 1, minus 1. Okay? That makes it easier to write. Then I have to have F here, which I found here 1, 0, 1, 0, 0, 1, 0, 1. So I have F here 1, 0, 1, 0, 0, 1, 0, 1. Okay, and now, so this works. This is a 4x4 and a 4x2. This is going to be a 4x2. And over here, I have to put the other matrix, the E2, which is just 1, 1, 1, minus 1. 1, 1, 1, minus 1. This is this one. And does that make, yes, okay. So let us oh, wow. Oh, good. I am recording. Okay. So that would be pretty bad. I forgot, but I didn't. Okay. So let's do this. This will be for, I'm not sure which way. If it's 4x2, 2x2 will be 4x2. So maybe this one will be the simpler one to do first. On the other hand, if I get rid of the big one first, that'll take a lot of work. So let's do that one first. If we can, a 4x2 times a 4x4 times a 4x2 is a 4x2. So there's our 4x2, and we'll just copy this down here. Will be 1, 1, 1, minus 1. Okay, that's better. Okay, so if we look, we have to do the row here and the row here. We're going to get a 1, right? Because only this one matches up, and we do this one with this one, the one matches up there. And then we come down here, And on the first column, a 1 matches there. In the second column, we have a -1. And then on the second row, we have 1, the third row rather. Third row times first is 1. This one times this one is 1. And then 1 and -1 is okay. And then we have 1/2, and 4 by 2 times 2 by 2 is going to be another 4 by 2, which is 2, right? 1 times 1 plus 1 times 1 is 2. Then this one will be 1 plus will be 0. This one will be 1 times 1 plus -1 times 1 is 0. And this one, let's see, this one here will be 1, 2. Because 1 times 1 plus -1 times -1. Then we get down to the bottom half, and we're going to end up, I think, with 2 and 0 and 0 and 2, and then the 1/2 will cancel all those 2s to give 1, 0, 0, 1, 1, 0, 0, 1. Well, that I'm not sure if that's what I wanted to have happen, but because I got this matrix out, but what it meant was that these sort of canceled out the effect. So what we'd have to do now is well, that was the triple thing, right? Maybe this example I just chose a problematic example because I've used the same basis over here that I used for each of these. So probably this was not a probably should. I wanted to do something simple, but maybe it was too simple because now if FBD is identical to FEE, it's not I mean, that's what would have to happen. So the question is now, is that going to happen? Okay, so I'm going to come over here. And we can do it just the normal way, right? We can just say, well, we want to do the map of F from B to D. So we take the image of 1, 1 under F, which over here is going to be 1, 0, 1, 0, right? But then we have to expand that in this thing, in this one here, which is going to be 1/2, I think. No, that's not, it's going to be something else. Let me, because this is not the same as we had before. Okay, so we this one will be, I think, 1/2, 1/2, right? Oh, sorry about that. I'm trying to expand this vector here on this basis here without having to write anything down. And I can see that this part up here is going to be a linear combination of these. I'm going to need to add these two with the same coefficient. So I'll get 2 and then 0. And this will be, so 1/2. I'll get 2. So this will be 1/2, 1/2. So 1/2 of this plus 1/2 of this will give that. But then lower down, also need the same thing down here, 1/2, 1/2 in basis D. And then 1 minus 1 under F is going to be 0, 1, 0, 1, which I think, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0 if we look at this basis here, we want to get the lower one here. So this is going to be 1/2 minus 1/2, 1/2 minus 1/2 in basis D. So I think then that,
Is this a new map?
excuse me,
Is this a new map?
this should be the same. Should be the same map as this one, XY, XY. Right, because the image of 1, 1. Oh no, what am I doing? No, okay. Yes, so that's why things are not working out properly. Okay. X is 1, Y is 1. So the image here is not 1, 0, 1, 0. It's 1, 1, 1, 1.
Oh, okay.
Okay, that explains what's going wrong here. Okay, because then, and that makes perfect sense. Because then the image is 1, but then I go back to basis D, right? That is 1 for this one and 1 for this one, because I've got 1, 1, 0, 0 and 0, 0, 1, 1. So this is going to be 1, 0, 1, 0. And then down here, 1 minus 1. Oh, no. Yes. So here, 1 minus 1 under F is going to give me 1 minus 1, 1 minus 1. Okay. Then over here, I will want, because this is the second one here, I want 0, 1, 0, 1. So therefore, F, B, this was, okay, this is like a terrible example. Okay, 1, 0, 1, 0, 0, 1, 0, 1. So by some weird effect, although it makes sense, I mean, although it does, it turns out that for this basis, FEE equals FBD.
Yeah, probably just different.
So it was like, yes, so it's sort of like, yeah, it doesn't, so it seemed, but there are different bases, right? So the problem is, because I chose them to be all sort of uniform like this, anyway. But this illustrates the two ways, the fact that you do get the same, we did get the same result down here from just multiplying them together. Okay? But my point was to illustrate that FBD was supposed to equal I from E4 to D, F E2 to E4, then I B to E2, because this goes B to E2, E2 to E4, E4 to D, and it has F sandwiched in between. Okay, so this worked out. These two sides of this equation are equal, confirming that it works. Unfortunately, it turns out because of I wanted to do something simple, but I chose basis as B and D such that somehow everything conspired perfectly to fit the matrix that represents F in the two maps seems to be identical. Okay. Well, I will go up and maybe what I'll do is I'll go and write and I'll write up another example. I'll do the same thing with a different example and put it up so you can sort of, I mean, the point is that the procedure is going to work even if the two matrices are different. The idea was that we got F from doing the simple thing, straightforward thing here. It turned out that that this new basis somehow conspired to give the same matrix map. And I'll go through and check this and make sure it's correct, and then put up either a revised form of this and put an example where they're not where FEE and FBD are not identical, but that this calculation works. And I have you do one of these on the on the assignment. On assignment 6. Your next to last assignment. So, okay, so this is what it's the point is this. You can see that for a given map, it was easier to do this intuitively, to just do the FBD directly. On the other hand, let's say you wanted to do the same transformation of these bases for 5 different maps. Well, you only have to do the identity matrix once. You find this matrix, multiply them together, get the map. You don't have to do any separate calculations. You can just put in different maps. Anyway, so this is what's going on officially behind the scenes of this sort of naive calculation that we're doing here, which is okay, but okay, that's all I wanted to do. That there's something here with this stuff.